Next, we'll look at the second method for determining which machine caused line downtime. And we call that initial reason. Let's use a process this time. And maybe we have a tank. And we come out of the tank through a positive displacement pump and into a heat exchanger. And then we have an ingredient that we're adding. And a second ingredient. We go through a mixer. And then we end up dumping it back into a finished product tank. So if we have values, so let's say we're reading from a slick, we have N70 that represents the state of that pump. In here we have N71 that represents the state of the heat exchanger, N72, and we just continue that on. And we could get fancy, and even our storage tanks could be at blame if they're full or something like that. But we'll just go with these right now. So we're going to monitor the state of this pump. And like we talked about before, 0 is stopped, 1 is running, and 2, let's call it a fault. Maybe it's a drive fault. Okay, could be as simple as that. So each of these have this. Maybe on this heat exchanger we have, yeah, 0 could be stopped, 1 is running, and maybe that really means our temperature is okay, and 2 is over temp or under temp, things like that. So we can pick up these downtime reasons by reading these states. But again, if something goes wrong, which one do we blame for the loss of production, the loss of gallons or liters going through our system here? So with initial reason, how this works in this mode is we monitor all of these cells or machines and we look for a problem. So for example, if let's say let's call this the HCl, mystery product X or mystery ingredient X, and H2O here. So we're monitoring all those, and we get a fault on our HCl pump. So it faults, and so we're getting a 2 in this case. We're reading 2 from N70, and that happened at 10:02 and 10 seconds. And then when that shuts off, we can't have our product without our HCl in it. So we have to stop, the process, and then the PLC program would stop the water right away. The temperature would start scaling back. This ingredient would have to stop because otherwise we just fill up the pipe with this ingredient and wouldn't have the water and the HCl. So everything stops immediately. There's no accumulation between any of these. So this may be stopped at 10:02 and 11 seconds. And this the same thing, 10:02 and 11 seconds. So we blame the line downtime in this example here with the first or initial machine or cell that went down. So our line downtime is going to be blamed on the HCl, and it will be, drive fault, something like that. So it's going to start when this goes down, and then once everything's back up, it will reset. So in this case, we picked up on the first machine that went down again, and that caused all the other ones to go down shortly after. This can also be used for like uniblock type machinery. Instead of a process, you have machinery that's mechanically or tied together. There's no accumulation between the different machines, and if one goes down, they all go down. You can pick up on that initial reason.